levels of measurements. There are 4 levels of measurement: nominal, ordinal, interval, ratio, and that order is important because it increases in complexity as you go from nominal to ordinal to interval to ratio. And if you want a mnemonic device to remember, the one I remember is that putting them in order spells out the word noir, which is just the French word for black, which means nothing and has nothing to do with levels of measurement, but it's how I remember what they are and the order that they go in, and that's what I've used since I first learned levels of measurement. So if that helps you, use it. If not, whatever. So when we're talking about levels of measurement, this is about the values of our variables. So anytime you have a variable, you're going to have at least 2 possible values, up to however many you want in terms of maximum. But because if you only have one value of a variable, it's a constant. So for example, if you have something like age is your variable, and then the values of your variable would be the ages that people say that they are. So the level of measurement then is about, well, how complex are the values of those variables? So how mathematically precise can we be using those values? So from a nominal, when we look at nominal levels of measurement, these are the only ones that are purely qualitative in nature, where there is no mathematical interpretation. They basically just categorize is what they do. Whereas ordinal, interval, and ratio measures are quantitative in nature, where the numbers actually mean something, and you get progressively more precise mathematically in terms of what you can do with them as you move from ordinal to interval to ratio. And so regardless of the level of measurement, though, you have to remember that the values of your variable have to be mutually exclusive and exhaustive. So those attributes have to be mutually exclusive, meaning that everybody basically can only fit in one spot. So if you have, for example, we're using a variable of age, and your values, instead of just letting people say what their age was, you had like categories. So you had boxes to check. So if you had your variable was age, and you had 30 to 40 and then 40 to 50 as 2 different boxes, then technically somebody who is 40 would fit in both the 30 to 40 and the 40 to 50 category. So that's not mutually exclusive because they could fit in either one. So that's why when you see like age categories on like a survey or something, it'll say like 20 to 29, 30 to 39, 40 to 49, so that everybody only fits in one spot. That's to make it mutually exclusive. And then it also has to be exhaustive, where not only can everybody just fit in one spot, but everybody has to fit somewhere. So you have to include all possible measures within your values of your variable. So for example, if you were to use the variable of gender, and you only have male and female, then people who don't identify as male or female would have no box to check, and then that's not an exhaustive measure. And so the questions don't actually have to necessarily be worded this way. Like you might have seen on surveys like a kind of check all that apply type option. And then you're like, oh, well, I fit in multiple of these things. And so that's not mutually exclusive. But actually the way that it is they just design the question that way so they can get a whole bunch of information within one question. But then each of those individual boxes that you could have checked becomes its own variable that's essentially a yes or no. And so each one is a yes-no question. And then everybody either says yes or no to every question. Otherwise, you can't analyze all those together. So that's kind of the way those work, just in case you were wondering. So let's talk about our nominal measures, which is starting at the least sort of that you can do with it mathematically. What nominal measures do is they categorize. So that is the only thing that they can do. You can't do anything with them. This is why they are inherently qualitative, because all you can do is show values have differences, but you can't do anything with those numbers except show that they're different. So the variables values they don't have any mathematical interpretation, and so that means the attributes of the variable, they differ in kind, but not in amount. So, and these are also known as categorical measures, is another way to describe them. So, for example, if you had something like gender or ethnicity, occupation, marital status, hair color, type of weapon used in an assault, anything where it's just you want to show differences, but you can't put anything in order, or you can't say something is bigger or smaller or greater or less than, you can't make those distinctions. All you can say is that they're different. That would be a nominal measure. And a very specific type of nominal measure is a dichotomy. Dichotomies are inherently always nominal by definition. If you only have two possible values of a variable, it is inherently, that means it's a dichotomy, which means it's inherently nominal. And so this is any time you variables only have two values. So this can be a truly nominal variable. So something like good versus evil, that would be truly nominal. You have just two categories. But the most common way that you see dichotomies within research is yes-no questions, or like presence, absence of something. So either it's there or it's not. Either they answered yes or no. So yes-no questions, super common dichotomy. So, was there a weapon used in an assault? Yes or no? So those are the types of things that, and again, if it's a dichotomy, by definition, it's nominal. So then ordinal measures, the next level up. So this has the same characteristics as nominal measures in that they categorize, but now we can also rank. We can put things in order, hence why it is an ordinal measure. So it provides that order, but there's no mathematical values still. All you can do is put things in an order, and that's it. So it lets us say, greater than or less than, and provides those distinctions, but it doesn't, we can't do anything else besides that. So, for example, if you look at, first, second, third in a race, let's say, then first was fastest, and second was second fastest, and third was third fastest. You can put them in that order, but the distance between them is not going to be constant. The distance between those ranks is variable. It's not always the same. But the difference is they do have some meaning where you can put them in that order, first, second, and third. And that, you could have first and second are neck and neck, and then third is way back here. So the distance between them isn't going to be the same. So some other examples besides, so you have like race, place in a race or a competition of some kind, but also something like offender risk level, low, medium, high. We can put those in an order, and that means something, but the difference between a low risk offender and a medium risk offender is not going to be necessarily the same as the difference between a medium risk and a high risk. And even within low and medium, there are differences. Level of violence in an assault. That's the same thing where we can say there's more or less violence, but we can rank that in some way, but it's tough to specifically quantify unless you're doing things like counting stitches or otherwise it's difficult to quantify specifically besides just being able to put that in order. Degree of social disorganization, another thing where you can say there's more or less, but you can't really, it's low or medium or high, but you can't really say that, you can't quantify those differences and they won't be constant. So then we're moving up to interval level measures. So now interval level measures are going to have everything from nominal and ordinal. So they're going to categorize, they're going to rank, but now the distance means something. It establishes that magnitude. So there's a real distance between those measures now. And so those numbers represent some kind of fixed measurement unit. So we can say that, for example, 20 degrees is 10 degrees hotter than 10 degrees, but it's not twice as hot because heat doesn't begin at 0, and 0 doesn't mean the absence of temperature. Hence, that's the absolute 0. So you don't have an absolute 0 in an interval level measure because an absolute 0 means the absence of that thing being measured. So temperature is a very good example of this because we can add and subtract temperature, and we can say the difference is this many degrees, but 0 doesn't mean there is no temperature. It's just on that scale. So you can add and subtract numbers, but ratios and starting to multiply and divide, you can't say again, like using that temperature example, you can't say that 20 degrees is twice as hot as 10 degrees. It doesn't work that way. It's just you can talk about 10 degrees difference, but you can't say it's twice as hot or it's half as hot as it was, or it doesn't make sense that way. So besides temperature, another example, if you have Likert scales that are designed to have equal intervals in some way, then a 0 on a Likert scale doesn't mean the absence of whatever you're measuring, absence of whatever you're using it for. Time of day, it would be a interval level measure, or dates. Similarly, they have constant differences between them, And so those differences, those intervals mean something, but you can't really use it the same way as you could if it was a ratio measure, which we'll get to next. Something like personality inventories, like your score on the MMPI, those differences mean something. Intelligence scores, so like an IQ test, the difference between various levels of IQ, those differences mean something. But you're not going to say somebody is twice as smart as somebody else. That doesn't really make sense. C level is another example. So anytime where you have those measures where the differences between your measures are constant and they mean something, it's an interval level measure. But 0 doesn't mean the absence of that thing you're measuring. And sometimes that's tough to know, so you kind of have to just really think about it sometimes. So ratio measures are, again, we have everything from all the ones before, so they categorize, they rank, they establish magnitude, but now there is the absolute 0. That's the difference. So numbers represent those fixed measurement units, same as with interval level measures, but now there is an absolute 0 point. So 0 means the absence of that thing you're measuring. So the quality being measured doesn't exist. And so because you have that absolute 0, now you can use ratios. So, for example, if you're using like income or money, then, if your income is 0, that means you have no income. And you can say somebody makes twice as much as somebody else. So it makes sense to use those ratios. Age, you can say somebody is like twice as old as somebody else. Or, distance, speed. And then kind of the easiest way, though, with ratio measures, sort of the most common examples of any type of ratio measures is anything that can be counted. If you are counting anything, it's by definition a ratio measure. So crime rates are ratio measures because 0 of whatever crime, a 0 rate of that crime means that crime does not exist. It's not happening. So you are counting the number of crimes that are happening, and so that is a ratio measure. And you can say there was twice as many murders this year as last year, or maybe half as many would be better. But you can make those ratios, you can make those comparisons because you have that 0 means there is none of that thing. So that's why I've got this Albert Einstein quote here, not everything that counts can be counted, not everything that can be counted counts, because it is that count measures, anything where you're counting people, charges, victims, crimes, anything where you're counting something, it's going to by definition be a ratio measure. So another little difference between variables is that they can either be discrete or they can be continuous. So discrete variables are where you have defined finite sets of possible values. And so it would be like if we think of our closed-ended questions versus our open-ended questions. Closed-ended would be discrete. And so by definition, all nominal and ordinal variables have to be discrete, because you can't make them continuous. But some interval and ratio variables are going to be discrete. So it would include things like counts and scores on intelligence or personality tests, because you can't get any number. So like you can only have a whole person or a whole crime. You can only get an answer right or wrong to count towards some final score in round numbers. So things like that would still be discrete, even though they're interval or ratio. But then continuous variables can take on any variable within either a specified range or a realistic range. And so the interval and ratio variables that aren't discrete are the ones that are continuous. So this would be things like temperature and weight, age, time. And so this is where literally any value is possible within that specified or realistic range. So like age, you can say, well, I'm like 20, but you could also say, well, technically I'm 20 and however many months and however many weeks or days or hours. You can go like right down to the seconds or milliseconds if you want to. So technically you can have a value anywhere within that. And so if you're just asking somebody, well, how old are you? And that's the question, and they type in their response, that's a continuous variable, because they could say, well, I'm 12 and a half or whatever. And that's a valid measure of your variable.